Hello everyone, welcome to another exciting lesson on decoders. And today I'll be explaining the 3 to 8 decoder, which is an essential combinational logic circuit used widely in the digital systems. Right, so a decoder is a logic circuit that takes a binary input and activates exactly one output line corresponding to that input combination. So this property is usually called one hot output. Right, so decoders are critical in systems like memory address decoding, instruction decoding, data routing, and even in binary to octal conversion. So let's explore how the 3 to 8 decoder works. So a 3 to 8 decoder takes three binary input lines named the A2, A1, and A0 and activates one of 8 output lines labeled D0 through D7. Now, at any time, only one output line is high, depending on the binary value of the input. So, for example, if the input 010, 010, if the input is 010, the output D2 will be high. And also, if the input is 101, then the output D5 will be high. Now, since the decoder with n input produces 2 to the power n output, a 3 input decoder has 8 output lines. Alright, so this is the truth table for the 3 to 8 decoder. So for each combination of A2, A1, and A0, exactly one output becomes active. Right, so what do we mean by that? So 000 activates D0, 001 activates D1, 010 activates D2, and so on until 111 activates D7. Right, so this table confirms the decoder's one hot nature, that is, only one line is on at any time. Right, so for the Boolean expression for each output, what we are going to do is the 0 will be taken as the complemented form, and then the 1 will be taken as the true form. Right, so each output is the result of a unique AND condition based on the inputs and their complement. So for example, D0 will have A2 complement, A1 complement, and A0 complement. D1 will have A2 complement, A1 complement, and then A0. So D2 will have A2 complement, A1, and then A0 complement. Right, so and so on until you have A2, A1, and A0 for D7. Alright, so this forms the basis for designing the circuit using the logic gate. Alright, so we are going to build the 3 to 8 decoder manually, and we are going to use a 3-NOT gate to create the inverted inputs for the A2 complement, the A1 complement, and the A0 complement. We're also going to need 3 input AND gates, each dedicated to one output. So each AND gate combines the correct version of the input to activate a single output. The gates are arranged so that only the correct input combination makes a gate output high. All other outputs stay low. So this is how the decoder achieves mutual exclusivity amongst its outputs, right? So without wasting much time, let's build the 3 to 8 decoder manually. All right. So as we said, we are going to need 8 AND gates. All right. So we pick our AND gates and then we build 8 of them. So they are supposed to be 3 inputs. So we select our 3 inputs and then we build 8 of them. So these are second one, our third one, our fourth one, our fifth one, our sixth one, our seventh one, and then finally the last one. All right. So they are all going to have an output. Right, so this is our first output, our second output, our third output, our fourth output, our fifth output,
Incoming mail.
our sixth output, our seventh output, our last output. Alright, right, so we are going to build our three inputs. Select three input lines. So this is going to be our first input. This will be our second input, and then this one is going to be our third input. And we are going to use three inverted gates, right? As we talked about. So we are going to use three NOT gates to create the inverted output. All right. So this is our first input line, our second one, third one. Right. So we create our NOT gate. So we are going to need three of them. So that's our second one, and then is our third NOT gate. Right. Right. So as we saw from the truth table, this one is going to be our D0, D1, D2, D3, D4, D5, D6, and D7. So as you saw, D0 takes 0, 0, 0, and we said that the 0 is going to be our complemented form, and then the 1 is going to be our true form. Right. So for 0, 0, 0, we are going to have uh, 0, 0, 0. So that's for D0. Then we move to D1. So for D1, from our truth table, we have 0, 0, 1. So for D1, we have so for D1 we have 0, 0, 1. So this one is for D1. Then we move to D2 where we have 0, 1, 0. So for D2 we have 0, 1, 0. Alright, then we move to D3 where we have 0, 1, 1. So for D3 we have 0, 1, 1. So we have 0, 1, 1. Alright, then for D4 we have 1, 0, 0. So for D4 we have for D4 we have 1, 0, 0. Alright, then move to D5 where we have 1, 0, 1. So for D5 we have 1, 0, 1. So we have 1, 0, 1. And then for D6 we have 1, 1, 0. So for D6 we have for D6 we have 1, 1, 0. Alright, and then for the D7 last one we have 1, 1, 1. So we have 1, 1, 1. Alright, so let's label our output. So this is D0, this is D1, this is D2, this is D3, this is D4, this is D5, this is D6, and this one is D7. Alright, so as we said from the definition of the decoder, we said that it takes binary input and activates exactly one output line. Alright, so for D0 our combination should be 0, 0, 0, right? So for 0, 0, 0 we can see that only D0 is high, the rest are all low. Alright, so let's try for 0, 0, 1. Alright, so we click here, simulate. So for 0, 0, 1 only D1 should be active. Then we do for 0, 1, 0. So for 0, 1, 0 only D2 should be active. And then for 0, 1, 1 only D3 should be active. So 0, 1, 1 D3 should be active. And then 1, 0, 0 D4 should be active. So 1, 0, 0 D4 should be active as we can see here. And then for D5 1, 0, 1 should be active. So 1, 0, 1 should be active for D5. And then 1, 1, 0 should be active for D6. So 1, 1, 0 should be active for D6. And finally 1, 1, 1 should be active for D7. Alright, so in summary, as we saw, a 3-to-8 decoder translates a 3 binary input bit into a 1-8 output. Alright, so only one output is active at any time, and it plays a critical role in digital circuits, especially in address decoding, control signals, and binary decoding. Alright, thank you for your attention, and I'll see you next time.